Gut. Please have a warm welcome for Sebastian Bergmann talking about alternative PHP runtimes.
That was a quick and painless introduction. Thank you, Toby. So I'm here talking today about alternative PHP runtimes, and the reason that this talk exists is because earlier this year, I think it was in January or February, my own PHP user group over in Cologne discussed topics that we wanted presentations on at some point through the year. And one member of the user group requested, hey, I heard about hip-hop and probably there are other alternative PHP runtimes out there for PHP. Can somebody talk a little bit about them? And I volunteered, and at one of the next meetings, I wanted to give a presentation on hip-hop because that was the only thing that I knew at the time. And while doing research on hip-hop, I came across at least 10 alternative implementations for PHP that are, at least to most of their authors, ready for production. Few of them actually are, but that's what we are going to have a look at in the next 45 minutes or so. So, when I proposed this talk, I said alternative in Cologne at that user group meeting, because the first question there after I started to talk for 3 or 4 minutes about how hip-hop works was, so you are explaining now how hip-hop works, which is an alternative implementation. Can you please also explain how the real PHP works so that I know what the differences actually are? So that prompted me to rename the presentation to PHP runtimes, and so I'm opening with a little bit of information about how the official PHP works. As Toby already mentioned, my name is Sebastian. I'm doing things with PHP and to PHP for almost 13 years now. I have a company with 2 good friends that are also well known in the PHP community, Arne Blankers and Stefan Priebsch, and we help development teams around the world leverage the PHP platform in a better way. So PHP, how does it work? When you think or when you say PHP, what you most likely refer to is the implementation of PHP written in C that you can download from php.net. That is now, I don't remember exactly, we had a 10th birthday and a 15th anniversary a couple of years ago. It's now 17, 18 years old, I think. So it's been around for a really long time. And ever since PHP 4, the implementation of the PHP runtime, the official one, is a so-called bytecode-based interpreter, which some people refer to as an interpiler, because it's a weird mix of a compiler, something that looks at your source code and turns it into something that the machine can interpret, and an interpreter which does not really look like a real compiler, but just takes an intermediate thing and executes it and then forgets about it. That's why you need to install something like APC, the alternative PHP cache, to do some bytecode caching and get rid of the compilation step in production. So what we have here is we read PHP source code, the PHP interpreter turns that into PHP bytecode, and then the executor executes that. And it's the implementation of PHP. Unfortunately, when compared to other programming languages out there, there is no official document describing what PHP is and how it should be implemented by other vendors, for instance. The only specification of the language that we have is actually in the form of the C sources for this reference implementation of the runtime. So if we have this really, really simple PHP script, the way that this is actually executed by the official PHP interpreter is that we read it character by character, and as soon as we recognize something like a word that we know that is part of the PHP language, we generate a token. So we read, and then the PHP interpreter says, hey, that is something I know, this is an open tag. And then we read 2 more characters, and hey, that's an if token. And we go through there, get more tokens. And that is the first phase of the PHP interpreter, or the PHP runtime's compiler, in fact, trying to figure out what you want it to do. So it reads character by character the source code and turns it into tokens as it recognizes them. If you have ever looked or dabbled in compiler internals somewhere at university maybe, this is called a scanner. A scanner reads source code character by character, turns it into tokens. So the next phase, which is the parser, can look at these tokens and in the first step tries to figure out whether or not you're using the words of the language in the correct way. And then the next step is to look at this tree, the so-called parse tree, and try to generate something that can actually be executed, which is, in PHP's case, the bytecode. So if you have ever done any sort of assembly language or looked at the JVM, the Java Virtual Machine, for instance, this should look familiar to you. It's a really simple bytecode. Every function that you write, including the functions that you don't write, which is if you just have a script and no encapsulation in there, no functions, no nothing, just plain PHP statements in a file, then that also is considered as a function. Every function is compiled by the PHP interpreter into a so-called op array. And an op array consists of multiple op lines. Each op line, in turn, consists of one opcode, and an opcode can have a result and operands that it operates on. So this very simple example of PHP code that we had looked at earlier is compiled down into these 5 opcodes. And if,
I don't want to dive into the details right now, but is there a purpose for the line 2 jumping to line 4 instead of line 5?
These are the lines that it comes from in the source code, where the opcode is generated from. And this is actually the number of the opcode, the address, if you will.
So it's jumping to number 4, not line.
Exactly, it's jumping to opcode op line number 4, and not to line 4, which is from the source code. If you ever wondered what your PHP source code looks like when it's compiled, there's a tool out there called ByteKit, which builds on Stefan Esser's ByteKit extension that gives you access to the bytecode at runtime. Can do interesting stuff with that. And if you look closely here and have ever done any sort of programming language implementation, you'll see that it is not optimized at all. So for instance, the print opcode has a return value. So actually the print statement in PHP has a return value that nobody ever uses. At least I've never seen it somewhere been used. And then the next line, because you're not storing that return value in a variable, it gets freed up. So that's rather pointless. And we also, and this is even a better example than the previous one, here at the end of the block, we jump unconditionally to the next line, so an optimizer could eliminate that and save a nanosecond or a quarter of a nanosecond or whatever. Those kinds of optimizations don't really give you anything, but it's just an indicator that there's no optimization going on at all. You can even look at it in a graph representation to get a better overview of how we're jumping around in the bytecode. And once we have the bytecode, the Zend engine's executor just starts with the first op line and just executes it and goes along until it finishes at some point, hopefully. Otherwise, eventually the process is killed, either by you because you get bored and don't want to wait any longer and hit Control-C, or because you run out of memory or something else. So at some point this gets executed and that's fine. It's also really interesting to see that we could get away with implementing all our fancy web applications just by writing assembler-like language code and not have all that syntactic sugar that PHP gives us, which is bad for your teeth, but in this case actually gives you really good productivity, because nobody, at least nobody I know, wants to write web applications in an assembler-like language. Although at the last CeBIT that I ever went to, some 8-9 years ago, there was one company exhibiting a web-based chat platform that was written for performance reasons in assembler, which was really weird. And they had something like PHP, but written in assembler, and you had to write assembler-like stuff. It was crazy. So when I first started to get interested in computers and started to learn programming, the term Big Blue referred to not Facebook, but to IBM. Nowadays, a lot of stuff happening with PHP and optimizing PHP and alternative PHP runtimes especially is happening over at the new Big Blue, because they ran into the problem that PHP actually became their bottleneck. Execution time-wise, so they wanted to improve the runtime of PHP, but also save a lot of energy costs. Because PHP, if you look at the interpreter, any interpreted language, in fact, wastes a lot of resources, CPU cycles, and thus power when trying to interpret the code. So they had the idea, or one of their engineers had the idea, hey, why not write a transformer that takes PHP source code as input, transforms it into C++, and then we can leverage a C++ toolchain, compile it into an optimized binary that is very energy efficient, and if it's in the end just a little bit faster than the real thing, then that's an added bonus, but we want to save on power costs. And that's how the hip-hop project was conceived. As I just mentioned, it takes PHP source code as input, transforms it into C++, and then you compile it down with G++, the GNU compiler collection, C++ compiler, into a native binary. In addition to that, in addition to having a piece of technology that transforms PHP into a native binary, you also need a runtime, because PHP as a language is rather useless, like any other language, if you don't have the standard library. If you cannot talk to the file system or cannot talk to a MySQL database, then this would just allow you to be really, really fast inside raw bytecode execution, but you would not be able to talk to the outside world, which would be rather boring and useless. So they re-implemented the most common PHP extensions, at least the ones that they need to run Facebook, re-implemented in C++, and they're just linked into your binary. And by the way, these binaries get really, really large. I remember the first time that I experimented with hip-hop during the week leading up to the public announcement of hip-hop actually existing and being open sourced. I was working with the engineers over there on getting PHP unit to run on hip-hop, because they wanted to be able to run their test suite of tens of thousands of unit tests, not only with PHP but also on hip-hop, to make sure that their code behaves exactly the same once it's compiled into a native binary than the regular PHP does. I remember that they looked at me really weird when I tried to compile PHP unit on my own laptop with just 2 or 4 cores. I don't remember which laptop I had at the time. I think it was still one that just had 2 cores. And they looked at me, this is going to take a really long time. You don't want to do that. You want to log into our compile cluster and compile it there. So it took a couple of 100 cores and 10-15 minutes to produce a binary that was a couple of 100 megabytes in size, and then I had something that I could work with. So it's a little bit different than you're used to work with PHP, where you just make a code change and hit F5 in your browser and see the result. So development really changes. But it turns out that it's also making good on its promise of being faster. So if I run the bench.php synthetic benchmark suite that comes with the PHP source code distribution that you can download from php.net, and run it with PHP 5.4 latest release, on my machine it takes 2.7 seconds, and using hiphop, same script, same machine, 0.8 seconds, so it's faster. To show it using a chart sometimes makes it much easier to see how much faster it is. So it's faster. Yes. But that's not the full picture, because once I type time in front of HPHP, which is the compiler and runtime environment there, you'll see that it actually takes 1 minute and 3 seconds, so 63 seconds to compile and run that. And if you add that into the equation, then the results look much different, but that's not the intended way of how hiphop should be used. But yeah, with PHP 5.4 we have compilation and execution in just 3 seconds, where with hiphop we have to wait for 60 seconds until it actually starts something to do really, really fast. And that turned out to be a real problem. Initially, the developers just thought, okay, this is really great for production, but as it only implements a subset of the PHP language and also has already some extensions to the PHP language that are not implemented in the official PHP, at least not yet. So for instance, they have the yield operator, I think, already that will be in PHP 5.5 eventually. They cannot use the normal PHP, the default PHP during development time, and then just hope that their code works just as well in production when compiled with hiphop. And clearly waiting 60 seconds or whatever every time you want to iterate through a code change and see whether or not it works is going to kill productivity. So this is really, really slow for development. It's fast in production, but really slow during development. And that's how the hiphop interpreter came to be, which is a different implementation of the same approach that the default PHP takes. So it's a real interpreter, and it works exactly the same way as hiphop when compiling into a C++ native binary. But you can just keep the same development lifecycle as you have with native PHP, but it's slower. It's still slower. It's not 63 seconds, just 4.5 seconds compared to 2.7 or something, but this is something that you can work with. So you know it's going to be a little bit slower during development time, but at least you're productive. Any questions so far? Feel free to ask anytime, yeah.
How is hiphop interpreter implemented if hiphop is a compiler to C++?
So the question was, how is hiphop interpreter implemented when hiphop itself or the main product is a transformation tool from PHP to C++ and then compiled into a native binary? The short answer, completely different. It has nothing really to do with hiphop, except that they share the same runtime library. But the source code is interpreted just as it is with the official PHP interpreter, but the runtime is the same.
So it has more to do with PHP itself than with hiphop,
yeah.
except for the runtime.
Yeah. This is how you would actually use it in your build step. You create a file that contains a list of all your files that you want to compile. And then you call hphp, and I'm calling it here with debug, not really debug output, but more verbose output to see what it's actually doing and how it's doing its thing. So it starts just as well as the normal interpreter does. It scans and parses the source code, then does optimizations. Biggest or the most important step here is the type inference step, where it tries to figure out what type each variable that is used in your project has. So for instance, if you have a variable and initialize that variable with an integer value, and throughout the whole code base, this variable is only ever storing integer values, then on the C++ level you can give it the native type of an integer and not an abstract data type that can work with all the different types that are available in the PHP language. This is one of the aspects where PHP internally at runtime gets really slow, because every variable is a so-called z-val, and that variable cannot really be optimized because it has to be able to store scalar types such as integers, floats, strings, but also more complex types like arrays and objects. Yeah.
So this means the memory footprint is significantly lower on hip-hop based?
Yeah. It uses the best native type everywhere where possible. Sure, if you're using PHP in a very dynamic way, then the type inference will show, okay, I have a variable here that at some point during execution has a string, and then it becomes an array, and then it becomes something else entirely. Then it will have to use the equivalent of a z-val. But then just this one variable will be slow compared to the others.
How do they know the type of the variable through the whole project? It can be gathered deterministic, I think.
Yeah, it's not.
So
it's
they may fail.
You need to.
Conventions for that.
Yes, they define a subset of the PHP language that you're supposed to be using. If you use very dynamic features of PHP, like for instance, if you invoke methods via call user func, or using the reflection API, or use variable variables or variable method calls or whatever, then it will not be able to figure out which code is actually called with what arguments and where they're coming from. So then it will just fall back to using the dynamic type.
Okay.
So to get the real benefit, you need to restrict the features of PHP that you're using. And those features that you're restricted to could be labeled PHP the good parts, in analogy to JavaScript the good parts. There was another question over there. Okay. Any other question? Okay. So of course, compilation time, as I already showed earlier, takes 61 seconds here. But it can be sped up. The more cores you throw at it, the faster it gets. So the fastest thing I can get it on my machine is to leverage 4 cores. And then that cuts it down in half to 34 seconds. If you have 10,000 cores available, it makes it even faster, at least for real life projects, like for instance the Facebook code base. Then only takes much less than just on a single core. But the binaries are really large. They go into the gigabytes, so they ran into the problem of, during deployment, how to deploy this large binary to all the web clusters, and they figured out that BitTorrent was actually the best solution for that. It's strange, but it works. While hip-hop is running, it creates a temporary directory in /tmp by default, where you can have a look at the C++ source code that is generated. This is useful for debugging the code transformation, for instance, or just if you're curious, like me, and want to look into what the C++ code actually looks like. You get the make file and also the binary, which in this case for this synthetic benchmark is 24 megabytes. Just to give you an idea how big these binaries go. This is pretty much the size of the runtime anyway, because there's just not that much code in there in that one bench.php. One thing that you also get here that's really interesting, at least to me, because I like to work on static analysis tools, is the code error.js file. This is a JSON data structure that contains all the information generated during type inference and static analysis that the hip-hop code transformer has to do in order to transform the code from PHP to C++. And I found this so interesting that I created a tool called HPHPA that parses this JavaScript file and gives you XML log files or textual output that you can use in continuous integration. And this can find really interesting stuff, really interesting code problems, like for instance, consistently calling a method in your code base with the wrong argument order or whatever, because it has all this information from the type inference available. But there was a question.
In the C++ files it generates, does it keep your comments and tries to keep your variable names so that you can easily find?
So the question was, in the generated C++ files, does it keep my variable names from the PHP source code? Yes, it does. In fact, that's the next thing that I wanted to show. And the other part of the question was whether it keeps my comments. As far as I know, it does not. But it has added comments in there that allows you to reference which area of the C++ code was generated from which area of the PHP source code, and that's used for debugging tools. So at runtime, you can trace back error messages from the native binary to the PHP source code file from where it was created. So this is just an excerpt from the bench.php script. So it's really simple. We have a function named simple with some stupid variable names in there, and we loop, I think, 1 million times and try to figure out how long that takes. So the purpose of this benchmark is to figure out how expensive function calls are, and if handling variables with longer variable names is slower or faster than shorter ones. I think that was one of the intentions back then. I don't know. It's a really long time since this benchmark was written, and it's not documented at all. It's probably even pointless. I don't know. But this is what comes out of hip-hop. And it looks very similar to the PHP code. There's a little bit of boilerplate code in there that's generated, but if you look at the for loop, it looks almost exactly the same as the PHP one. Okay, so that's hip-hop. It's been in production at Facebook now for a little over 2 years. I think 1 or 2 other companies are using it or are experimenting with it. I don't think it's suited for really much more than maybe 5-10 other companies, I don't know, because it's really hard to adjust your development process around this runtime. But it's not the only solution or the only alternative implementation of the PHP runtime. Over the last couple of months, almost every 2 weeks, I came across a new implementation of PHP. Yeah, just one spoiler, none of them are as far and production ready or production proven as hip-hop, which is the only one that I know that somebody is actually using in production. One of the newest one is called HippieVM, which also comes out of Facebook. Although they are really happy with hip-hop, they are looking for even better solution, even better alternatives. So this was something that could be compared to a 20% project over at Google. Something did that not really in his free time, but on company time. But yeah, so they did a study where one person worked for 2 months on trying to implement PHP with the PyPy toolchain. PyPy is not really Python implemented in Python, but implementing a re-implementation, rollback. A compiler and an interpreter construction set that uses Python as its core with the intent of building a new Python runtime using Python-based tooling, which is a really long explanation for a complicated project. So they had the goal, one person, 2 months, get as close to PHP as possible, just to make a feasibility study of whether or not this would make sense to implement a different PHP runtime using PyPy. And as is often the case, the Pareto principle applies, the 80-20 rule. It's really easy and really quick, and this study showed that, to implement 80% of the PHP language in just 2 months by a single person. It's the 20% that come after that that are probably going to be really, really hard. So another thing that they're currently looking at is the MLVM, the Da Vinci Machine project, as it's also called, which comes out of the Java community process. And the Java community calls this, yes, this opens a golden age for getting other programming languages on the JVM, especially dynamic languages. It's going to be a multi-language renaissance for the JVM. Finally, we get other languages on the JVM that actually are viable compared to Java, and languages that are closer to Java than Python and Ruby and PHP, for instance. So they built in first-class architectural support for dynamic languages. So it's much easier and much more efficient to implement those on them. And I don't have any first-hand knowledge about that, but I just heard rumors, just like everyone else. There was a blog posting, I think 2 weeks ago, that mentioned that Facebook is working on an MLVM-based implementation of PHP, or at least thinking about doing that. So that might be some interest. That we might hear some interesting thing about PHP on MLVM at some point in the future. But by the way, that was not the first, and it's probably not going to be the last implementation of PHP on the JVM. So what other ways could we implement a PHP runtime? There's also HappyJIT, which also is based on PyPy, but at least as far as I could figure out, they took a much more academic and, in my opinion, saner approach than HippyVM when trying to build a PHP runtime using PyPy, in a way that they tried to reuse existing code. So these guys, they just care about optimizing bytecode and executing bytecode as quickly as possible. So they did not want to write their own scanner and parser and bytecode generator. So they just took the Zend engine's parser, or actually the whole compiler from the Zend engine, and have that in the same way as the native PHP that you can download from php.net, compile PHP source code to PHP bytecode, and then transform that PHP bytecode in something that can be understood and optimized and executed by a PyPy-based runtime. And since the Zend engine does not provide an API out of the box to get to the bytecode, they use, or app use, if you will, APC, the alternative PHP cache, to get that bytecode. And then they have their thing called BC Parser, which is a bytecode parser. It's a tool built on top of the PHP bytecode representation. And then they transform it into their own optimized bytecode, and then have a PyPy interpreter that runs that.
Are there any stats on how long that process takes? Like, is this actually usable in development for an interactive use? Or
I couldn't find any information on how useful it would be. I mean, just look at the URL. The only information you can find about this project is an academic paper that was recently presented at a conference. It's interesting to read, but has no real industry relevance in there, at least as far as I could find. But it's nonetheless really interesting. Also interesting, but probably useless, is php.js. It's a PHP interpreter implemented in JavaScript. I think this is also a good example where the 80-20 rule applies. It's probably really fast to implement the easy bits and pieces of PHP in JavaScript, and then it gets hairy. This is what it looks like. You create a PHP object and pass it in the constructor, the PHP code that you want to execute. And by default, it just logs all of the output in an output buffer, and you have access to that via engine.vm output buffer, and then you can just write that to command line, and it sort of works. I wasn't able to get it to work on my machine, neither with SpiderMonkey nor with V8. Got weird error messages with both. It did work fine, however, in Firefox and Chrome on the website, where you can actually experiment with it. So you have a basic HTML page where you have a form field where you can put PHP code in it, and it will run it in the browser, and you can experiment with it a bit. So that's that. Yeah, that's actually the demo that you can look at there. Yep, it seems to work. There's also Phalanger, which compiles PHP down to Common Intermediate Language code, which is the bytecode of the Microsoft.NET runtime. By now, it's actually supported and sponsored by Microsoft. It started as an academic research project at Charles University in Prague, and they get now help from Microsoft. Microsoft is really interested, just like whoever owns Java these days, getting native support for the JVM to be a viable target for dynamic languages. Microsoft has the same problem or interest, depending on the way you want to look at it, to get dynamic languages compiled there. Even before hip-hop, there was a way to compile PHP code down to a native binary. This is the PHP compiler. This started as a research project at a university in Ireland, I think. Project still exists, still works. Doesn't really implement a recent version of PHP, but it's nice to work with because, not necessarily because it gives you a native binary, but because along the way it gives you an abstract syntax tree of your PHP source code in XML format, and you can do interesting stuff with that. For instance, use XSLT, like checking rules on that, and replace PHP code sniffer or PHP mess detector with that, and operate on that abstract syntax tree if you want. There's also ROSE, which stands for the ROSE compiler, and this is, I almost said scary, but in a different way, I think. This comes out of the Lawrence Livermore National Laboratory. This is a lab where, for instance, the US military has its stuff developed. I don't know why they need that. It's a framework for source code to source code transformation, so the stuff that hip-hop does, but also for static analysis, and it supports a really wide range of languages. They have been working on this for a really long time, and somebody a while ago implemented a PHP front end for that, so it can understand PHP source code, and all the tools that the ROSE toolchain gives you can do interesting stuff with PHP code. This is a funny one because the name of both the company and the product are Road's End, and the project has hit the end of its road because it's no longer maintained. So it was also it was a commercial product that turned PHP code into native code. Don't know if it actually worked. It's being rebooted at the moment on GitHub by one of the original developers, and he's going a completely different approach. He's compiling PHP to bytecode for the LLVM, also with a C++ runtime. I have not been able to run actual PHP code through that, but I was able to get an abstract syntax tree in XML format and try to figure out some good static analysis on that. At least interesting just for that. Talking about dead things, there's pip, which is Parrot's PHP. Parrot, the Perl 6 runtime. Somebody wrote a compiler for that. It's dead. Even when it was not dead, I wasn't able to get it to work. I tried 2 years ago, so just couldn't get it to work. There's Quirkus, which is also, it's a quirky name, but apparently it works. I wasn't able to try it, but I heard that they do have customers and they do use it in production. I don't know how well it works. It's an implementation of the PHP runtime in 100% Java. You can even extend the language, write extensions for it in Java. This is what it would look like. Not really interesting. There's also IBM WebSphere Smash, or whatever it is called this year. Because it was renamed so many times. Initially it was called Project Zero, then they made a product out of it and called it IBM WebSphere Smash, and I think it now has a different name. The story goes that a really big customer came to IBM, remember the old Big Blue, and told them, hey, we have these cool PHP applications that we want to run on our hardware, but we only know how to run the JVM in production on our IBM iSeries stuff. So could you port PHP to the JVM? And apparently IBM did that. So it compiles PHP to Java bytecode and has C-level PHP extensions from the official PHP project, like a DSO, a shared library, that it accesses through the Java native interface, GNI, to access the PHP standard runtime. And the last one, I was this close to not actually including it in here because there were a couple of months ago, there was a big announcement from a stealth startup over in the US that said, hey, we have re-implemented PHP. It's 10 times faster, 10 times more scalable. It's really awesome. We're able to run Drupal and WordPress and whatever other important applications 10 times faster and in the cloud and bingo and whatever. And I tried to get in contact with them and said, hey, I would like to play with this because I cannot really believe all of the things that you're claiming. And just this morning, I got an email from them with access to the private beta, and it seems to work. Not sure exactly what they're doing. They re-implemented PHP in another, I don't even know in what they implemented it, probably C or C++. And it's able to run 10 times faster, or so they claim. I hope to get my fingers on that and have a play with it and see whether or not it's just marketing speak or not. And final slide, trade-offs. There are always trade-offs. Like we saw with hip-hop versus PHP, which led to the implementation of hip-hop interpreter. You have to trade off between development time and performance in production. You have to trade off between just using a small subset of the PHP language or the full capacity of the official PHP, which probably will always be the canonical version of PHP, where new features are implemented first. But if you are in a position like this one company that supposedly only wants to run JVMs and want to run PHP on the JVM, then making do with a subset of PHP that works on the JVM might be the trade-off that you have to make or want to make. So I'm getting signals from at least 2 people in the audience that I'm out of time. That's good because I'm also out of slides. So I timed that one perfectly, it seems. So any questions? And I hope this was interesting, although at least to me it's really interesting because I'm really interested in programming languages, different ones of them, and how they are implemented and what you can do with compiler internals and so on. The first time I gave this talk, people came to me afterwards and said, this was really interesting, but I cannot use this in production because this doesn't seem to fit my development style, but hey, still seems useful. Now I know more than before. So I hope it was useful to you in one way or another. Toby.
How good is PHP unit running on hip-hop? Are the developers able to use all functionality of PHP unit, or is it also?
So the question was, how well does PHP unit work on hip-hop, and is all the functionality available? Short answer is, it works. It works at least for Facebook. Outside of this 1 week at Facebook, I was not able to get it to work because but I also have to say I didn't really have the motivation to try because it just takes too long. You have to think about the fact that if you want to compile it, you have to compile your own application, the code base, plus PHP unit, plus your tests, and then you get one binary that you run, and it will run your tests through PHP unit. I never actually tried running it, trying to run PHP unit and a test suite using hip hop interpreter. But it should work. Well, it will be slower, but you should have everything available in there. And all features should work.
Do you know of thread safety with regard to any of these alternative runtimes?
So the question was, do I know anything about thread safety with regard to the other runtimes? No, I do not, but they have to have the same problems that PHP has. So the PHP runtime itself is thread safe. It's just that if you link in extensions that use libraries that are not thread safe, then you run into trouble. And since it's a problem with that library, any application, any interpreter built in C or C++ that links against that library will suffer from the same problem.
But I thought some runtimes implemented some extensions themselves.
Right, some of the runtimes implement the extensions themselves, but they probably don't re-implement the libraries that these extensions link against. I highly doubt that anyone working on such an alternative runtime re-implements.
Except Quarkus, maybe.
Yeah, except Quarkus yeah, I don't know, but they don't offer that many extensions to begin with. So some of the image libraries, for instance, that are commonly used, they are not thread safe.
So people always ask these questions about hip-hop. Have you ever actually seen anyone other than Facebook run hip-hop? Hip-hop, leave alone whether it makes sense or not. Is there anyone in the audience who has actually run hip-hop in production or knows anyone who's done that?
I talked to 2 companies that are experimenting with it. They are able to compile their code base now. They spend a little bit of effort on that, on getting it to run. So basically, they refactored their code base to the subset that hip-hop defines. They're able to compile it. They would be able to run it in production. They're just not doing it because they don't really have the kind of problems that Facebook has. But it would be possible for them, but they would have to change their development and especially deployment cycle for that. But as I mentioned in the beginning, I highly doubt that there are many companies that have the same problems and are looking or are in need of a solution like this. But for me, as someone who is interested in compiler implementation, it's a fun topic to look at every once in a while. And when I do that, I don't really look at whether or not it's actually useful or not. Yep. One of the few things where I allow myself to be not looking at how useful something is, yes.
Are there actually benchmarks where you just look at the already compiled bytecode of the normal PHP runtime versus the hip-hop one? Because from my point of view, when you measure when you're using opcode cache like extension, PC and stuff, most of the time you don't have to use you don't have that compile time.
Yeah, so the question is valid. The question was whether I considered in doing this benchmark comparing PHP with both compilation and execution versus hip-hop with compilation and execution as separate steps. So compiling this tiny benchmark script with PHP is so fast that it doesn't really matter.
Yeah, I mean just splitting the compiling phase for both, just the...
There's no real way to measure that. It's not really that significant. I tried, but I got really close numbers. Like, I reran it and got different numbers again, and ran it a couple of times, and it's so close. It's so inseparable, because even if you... So with this short script, compiling about takes the same time as loading the bytecode from the cache and using it. At least that's my interpretation of what I observed. Maybe Hartmut or somebody else who works on the interpreter, or used to work on the interpreter at least, can shed some more light on that. Any other questions? No more time. Okay, thank you.